Dear students, let us study about the various types of redox reactions. Combination reactions. A combination reaction may be represented as A plus B gives C. Now, for a combination reaction to be a redox reaction, either A or B or both A and B should be in the elemental form. See the reaction where magnesium combines with nitrogen to give magnesium nitride. Here, in the reactants, magnesium and nitrogen both have oxidation number 0. In case of magnesium nitride, the oxidation number of magnesium is +2 and the oxidation number of nitrogen is -3. There is a change in oxidation number from reactants to products. So, this is a redox reaction. Also, all combustion reactions are redox reactions. Look at the equation. CH4 plus oxygen gives CO2 plus water. This is the combustion reaction for methane. Now, when you calculate the oxidation number, see in case of carbon, in methane, the oxidation number of carbon -4 changes to +4 in case of carbon dioxide. So there is a change in oxidation number of carbon. Similarly, in the reactants, oxygen in the elemental form has oxidation number 0, and in products, in case of water, oxidation number of oxygen is -2. So the combustion reaction is a redox reaction. Next, we will study decomposition reactions. For a decomposition reaction to be a redox reaction, the decomposition reaction should lead to the breakdown of a compound into 2 or more components, and at least one of the component must be in the elemental form. Let us see the decomposition reaction of water. Now, in case of water, hydrogen has oxidation number +1. When it decomposes to form hydrogen and oxygen, the oxidation number of hydrogen changes from +1 to 0, and the oxidation number of oxygen changes from -2 to 0. So this decomposition reaction is a redox reaction. Similarly, decomposition of sodium hydride. In this case, the oxidation number of sodium changes from +1 to 0, and the oxidation number of hydrogen changes from -1 to 0, and this is again a redox reaction. Now look at the decomposition of calcium carbonate. Is this decomposition reaction a redox reaction? Let us calculate the oxidation number of each element in calcium carbonate. Calcium has oxidation number +2, carbon has oxidation number +4, and oxygen has oxidation number -2 in calcium carbonate. Now see carefully that there is no change in oxidation number of calcium or carbon or oxygen when calcium carbonate undergoes decomposition. So this decomposition reaction is not a redox reaction. Students, you must remember that all decomposition reactions are not redox reactions. Next, we will discuss displacement reactions. In a displacement reaction, an ion or an atom in a compound is replaced by an ion or an atom of another element. It may be represented as X plus YZ gives XZ plus Y. Now see this metal displacement reaction. Cr2O3 plus 2 aluminium gives aluminium oxide, Al2O3 plus chromium. Now see the oxidation number of aluminium changes from 0 to plus 3. The oxidation number of chromium changes from plus 3 to 0, and this is an example of metal displacement reaction. All alkali metals and some alkaline earth metals like calcium, strontium, barium displace hydrogen from cold water. So you can see in the first equation the oxidation number of sodium changes from 0 to plus 1. The oxidation number of hydrogen changes from plus 1 to 0. So these are redox reactions. Let us see the reaction of zinc and HCl. Students, many metals are capable of displacing hydrogen from acids. So zinc reacts with HCl to form zinc chloride and hydrogen. The oxidation number of zinc changes from 0 to plus 2. The oxidation number of hydrogen changes from plus 1 to 0. So this displacement reaction is a redox reaction. Similarly, iron reacts with HCl to form ferrous chloride and hydrogen. See, the oxidation number of iron changes from 0 to plus 2. The oxidation number of hydrogen changes from plus 1 to 0, and both of these are examples of redox reactions. Bromine can displace iodide ion in solution. So bromine plus iodide ion gives bromide ion and iodine. You should balance the equation. See that oxidation number of bromine changes from 0 to minus 1, and oxidation number of iodine changes from minus 1 to 0. Another very important class of redox reactions is the disproportionation reactions. In a disproportionation reaction, an element in one oxidation state is simultaneously oxidized and reduced. Disproportionation reactions are a special type of redox reactions. So, one of the reacting substances in a disproportionation reaction always contains an element that can exist in at least 3 oxidation states. The element in the form of reacting substance is in the intermediate oxidation state, and both higher and lower oxidation states of that element are formed in the reaction. So, one of the reacting substances in a disproportionation reaction will always contain an element that can exist in at least 3 oxidation states. A very familiar example of disproportionation reaction is the decomposition of hydrogen peroxide. So, hydrogen peroxide decomposes to give water and oxygen. Now, students, see carefully. In hydrogen peroxide, the oxidation state of oxygen is -1. In case of water, the oxidation state of oxygen is -2. And in O2, oxygen exists as elemental form and the oxidation state is 0. So this is a disproportionation reaction. Oxygen can show -1, -2 and 0 oxidation state, and this will become an example of disproportionation reaction. Another example of disproportionation reaction is chlorine reacting with alkali OH minus to give ClO minus, Cl minus and water. See carefully, in the reactants, chlorine has 0 oxidation state, and in ClO minus, that is the product side, chlorine has +1 oxidation state and Cl minus has -1 oxidation state. So you can see that chlorine is undergoing both oxidation and reduction. Chlorine Cl2 is oxidized to ClO minus with increase in oxidation number, and chlorine Cl2 is reduced to Cl minus with a decrease in oxidation number. The reaction has a practical application as it describes the formation of household bleaching agents. Now let us take up a question. Which of the following species do not show disproportionation reaction and why? Out of these 4 options, we have to decide which of these will not show disproportionation reaction: ClO minus, ClO2 minus, ClO3 minus, and ClO4 minus. So for this, you have to calculate the oxidation number of chlorine in all these species, and when you calculate the oxidation number, you will see that the oxidation number of chlorine in ClO4 minus is +7. So it will not be able to show the disproportionation reaction since oxidation number of chlorine is in its highest oxidation state, that is +7 in ClO4 minus. So amongst the oxo anions of chlorine listed, ClO4 minus will not disproportionate because in this oxo anion, chlorine is present in its highest oxidation state, that is +7. Students, I hope you have understood the types of redox reactions well. Please like and share the video, subscribe to the channel ChemBank, and press the bell icon to never miss an update. Thank you.